parentheses, Cr2O7, close the parentheses, 3.
Is dichromate?
It's Cr2O7. Did you get CrO4?
I just did it.
It's on the chart.
Did you do it?
It's like it's actually done.
Yeah, that's actually on here.
Like you like died.
Oh, because I thought that it was
Old system?
Yeah.
Yeah, no, it's there's 2 exceptions on there, dichromate and diphosphate. They're polyatomic ions that you have to look up.
What I had is I did chromate. I didn't do dichromate.
All right, number 14. Both of these have oxidation numbers of 1. You may have parentheses if you want them, but there are no parentheses necessary. So it would be NH4, C2, H3, O2.
So you didn't have these parentheses?
NH4, C2, H3, O2.
And there's parentheses on both of them?
You can have parentheses on both of them if you would like, but there's none necessary. Number 15 is one of your acids, HNO3. Number 16 needs to be reduced. You have a 2 and a 4. So if you did not reduce, you would have SN2, parentheses, CO3, close the parentheses, 4. That would cost you one of your 2 points tomorrow.
Wait, you said 16?
Yeah.
No, you said if you didn't reduce.
If you didn't reduce, it should be SN, parentheses, CO3, close the parentheses, 2. Number 17 needs to reduce also. It's S2O6, so you have to reduce it into SO3. Number 18, CO, parentheses, OH, close the parentheses, 3. Number 19, Cr2, parentheses, PT, Cl6, close the parentheses, 3. And the last one, Ca3, N2. Yep. Number 19, let me start with what we've got, and then we'll go from there.
It's a polyatomic.
Yes, it is.
Never mind, I looked at the wrong thing with the wrong.
Polyatomic ion?
Can you do number 1?
Yep. Let me do 19 real quick.
Oh, wow.
You don't need it? Okay. So number 1. Number 1 says Na2,
Sodium.
S2O3. So after you have that, all right, Na, the first element is sodium. After you name the first element, you want to look up everything after that first element for one name. Okay? So you want to scan your polyatomic ion list, Annabelle, for S2O3. Okay? And find S2O3 for one name. Do you have the oxidation sheet?
Yeah.
So look for S2O3 and find its name. Okay, it's pronounced thio. All right, and then sulfate. Now, how do we decide if it needs a Roman number? You look at sodium. So look up Na on the oxidation sheet. How many numbers are listed beside the sodium? Only one number. So if it only has one number, does it get an oxidation number or a Roman number? No. So we don't put anything beside it. It's sodium, thiosulfate, and we're done.
Number 5.
Number 5 says Fe3. All right, so Fe is iron. This one's in parentheses, so it makes it a little easier. We know it's a polyatomic ion if it's in parentheses. So you're hunting for that C6H5O7 is one thing. What's its name? Okay, it's pronounced citrate. Okay, so iron citrate. So, does iron need a Roman number? Okay, so what Roman number are we sticking here beside the iron?
2.
All right, that 2 right here came from iron, so that's why we put a 2 beside iron.
Okay.
That's how we do that.
That's all.
That's it.
Okay.
And you can do that for all of them. There's only one that I've expressly stated on the test. You must do an old system. One. Huh?
Manganese.
Manganese. What about it?
The one that you're talking about, she wants to know what it is.
I'm not going to tell you which one I've required to be written in old system.
Oh, I thought you like.
There's one question on the test.
Something about manganese that is special.
I said a lot of people confuse it with magnesium.
There was something you said.
Yeah, people confuse it with magnesium a lot. But I won't tell you which question. It's on my desk. I moved it front and center so people could find it a little easier. Clearly it didn't help.
One do another one. 13.
All right. Can you tell me why none of those can be written with old system? Just quickly before we go on to 13.
Old system is with the prefixes.
Why can't I use the prefixes in any of those? Why'd I have to do like sodium and no prefix? Use a Roman number. I could use a prefix.
Small.
Yes, ma'am.
Please send Cameron Harrison to the office. Please, he's signing out.
I will.
Thank you.
Welcome.
Isn't it because it goes with the second thing? And
What is this element right here and this element right there? What kind of element are they? Are they metals or non-metals?
there's blood metal.
That's right. Since they start with metals, I can't use a prefix. I can only use prefixes if they're non-metals.
Yeah.
Okay? So that's why I can't do it. The only ones on that 1 through 10 list that I could use prefixes on have to start with non-metals. So you could do the prefixes on like number 7, number 6, and number 9.
Yeah.
Okay? Everything else starts with a metal, so you can't use prefixes on the rest of them. Okay? So if you're not sure tomorrow which system to use, don't use the prefixes. Just name the way we just did it. Okay?
Number.
So 13. You know that sheet last week that I told y'all not to lose? It looked like it was photocopied out of a textbook. It'll be off that sheet.
Can I use a staple?
Yeah. All right, so 13 says antimony, 3-dichromate. So what's antimony symbol?
SB.
Okay, so SB. All right, the 3 means what?
3.
Okay, that means its oxidation number is a 3. All right, so now you got to hunt up dichromate. This is the one that Linda and I were talking about a minute ago.
CR207.
Okay, CR207. Okay, what do you do anytime you have a polyatomic ion? Okay, now what do I do with the 2 and the 3? Okay, so 3 comes over here, 2 comes over here. So SB with a 2, CR207, and you have a 3. That's it. Now, make sure you always check to see if this 2 and this 3 can be reduced, but I always check here. I check before I crisscross. Okay, so if you look at the one that had the carbonate that we were talking about, the one that said 10-4, SN out of 4, carbonate has a 2. I notice when I do this, before I ever crisscross, I notice there. do I need to reduce?
Yes.
Yes. So before I even crisscross, I know I need to reduce. So when I put in my parentheses and I bring my 2 down and my 4 down, I know I have to reduce. Okay? Because I noticed when I wrote my oxidation numbers down, I have to reduce. So I know this 2 and this 4 in math class reduced to a what?
1 and a 2.
A 1 and a 2. So when I rewrite, that's going to be a 1. That's going to be a 2.
So how do we do that when we're going like backwards? Like,
What? Figure out the oxidation number? You have to check out the second element. Okay? So let's say that I gave you PbCO3 with a 2, and I wanted you to figure out the name. Okay? You know that this is lead. You know CO3 is carbonate. All right? Look up carbonate's oxidation number on your sheet.
it's -2.
It's a -2. It's supposed to be right there. But that 2's not right there. So what does that tell you happened? It was reduced. So now you need to take the 2 and multiply it through the formula. And you know that it was Pb2CO3 with a 4. Okay? So what number came from the lead?
4.
That's how you do that. You got to check the second element. Okay? Anything else on naming? All right. So where does the test start again? Atomic structure. So if you look back in your notes, if you start with where it said the 2 parts and the 3 parts of an atom, that's the beginning. And it ends with where we did mole conversions with moles to formula units, moles to molecules, that part of your notes, okay? It should not start at percent composition. That's the beginning of the next unit, okay? Everything in between in your notes is what's on the test, okay? Now, we're going to go back to empirical and molecular formulas today. We started those on Friday, so find your notes from Friday, because you've got the notes. We're just continuing them from Friday.
Do we need anything out?
You need a periodic table and a calculator. All right, so on Friday, we wrote down the steps to be able to find an empirical formula. And we said to do this, we would change percent to gram. And in order to change percent to gram, what did we do on Friday? We just wrote it. We took the percent off and we wrote grams. Everybody knows how to change percent to moles or grams to moles at this point. And then the third step was we divided the smallest number by itself and all the other numbers by that same smallest number. And then in the problem we did on Friday, everything turned out to be a whole number and we wrote the formula, right?
Yeah.
But does everything always turn out to be a whole number?
No.
No. So we haven't done a problem where everything didn't turn out to be a whole number. So now we need to learn how to do something where it doesn't turn out to be a whole number. So that's what we're going to start with.
Can we write that?
Yep.
What are we telling them?
Empirical formulas. It's the same topic. We're just continuing what we did Friday. Just add it to Friday. It's the exact same topic. You can't? Then title it empirical formulas. People had missing today. I haven't done the attendance.
Dylan just left.
Dylan gets marked absent for the day.
I think that's
This
it.
one half the class.
I think it's the only one. Yeah, that's it.
Picture? Oh,
There's.
Yeah.
wait, she's an O.
Nah.
But they called her.
Okay, I will talk to you.
Yeah, he lied.
Are you staying today, Miss Wong?
No, I'll be here Tuesday, Wednesday, Thursday.
Oh, today's the day, isn't it?
I mean, is there something you need this afternoon that I need to stay for?
We have a test tomorrow.
Silly.
I mean, I can't stay, but I'm
Given I was already staying 3 days this week, I didn't think I needed to stay today.
Well, all the days tomorrow.
We'll take off Thursday and stay today.
Why? Do you need to stay today or something?
I don't know.
I'll
So what are we supposed to be finding?
I'm so confused right now.
What, oh, we, never mind, I get it.
Oh, my God. Oh, dang it.
Oh, I haven't told you what, or we haven't talked about it, but have you got it written?
I'm so
All right. So what's the first thing we did Friday? Change it to grams. So you're still going to do that, okay? So we're going to take the percents off, and we're going to change it to grams. So 26.56 grams of K. 35.41 grams of chromium. And 38.03 grams of oxygen. Now, is everybody okay with changing the percent to grams?
Yeah.
All right, so step 2 should also be a step we're still all okay with. We're going to change grams to moles. Why? All right, so on the test tomorrow, because these are all fair game for the test tomorrow. Not doing an empirical formula, but changing grams to moles would be on the test tomorrow. All right, so what would go beside moles on the test tomorrow? 1. What would go beside grams on the test tomorrow? The atomic mass, because these are singular elements. Okay? You will have problems on the test tomorrow that are single elements, and you will have problems that are compounds. You will see both tomorrow on the test. So single elements, you will look up their masses where?
On the
periodic table.
Wait, for the ones with multiple, do we do the 2 times?
Yes, for the compounds, you'll have to break them apart, multiply by their subscripts, and add them all up. Yes. Okay? So potassium's what? 39.1. Chromium's what? 59.9 or 52? What's on your table? 52. Used to be 51.9 once upon a time. Your guess is as good as mine. And remember what I said. When you calculate your moles, you want to take it out several decimal places. Don't round off too much, or you wind up with the wrong answer. All right, so we've done step 2. We've changed our grams to moles. So step 1 was change percent to grams. Step 2 was change grams to moles. So step 3, picking the smallest number and dividing. So which number up there would be the smallest? The first. So we're going to divide it by itself. So if I divide this one by itself, we get a 1. If I divide this one by 0.6792, I'm going to get 1.00 and some really tiny little numbers behind it. So that's the same thing as 1. Now, I want everybody to divide this one themselves to see what you get.
Okay, just give it 1 second.
I'll be glad to.
I have a question.
Yeah,
Why don't we take the smaller number?
because that's how you get whole numbers. If you don't divide by the smallest number, you're not going to get whole numbers.
Okay.
3.
Yeah, sorry about it. Okay. I haven't typed in.
But wait long enough for Annabelle to catch up.
I don't think so.
And the what?
Like, how's
How do you get
6,809 divided by 0.67921?
Just divide it on the calculator so you can see.
So do you round it to 1?
Divide it on the calculator if you don't believe me.
I did, but I didn't round to 1.
It's like 1.00.
So basically,
It's 1.002 or 1.001. It's basically 1.
1.
It's a lot. Yeah.
Which was my point.
I'm almost done.
What do you got?
Okay, I'm almost done now.
Because I can stay side here and find this. I want some chips in third. I got the bandsaw of chocolate in second.
I know it's
Yes. Fabulous. What's the answer?
I don't want to say it because I may have done it. Check.
What'd you get?
3.49.
Yes. Now,
What's the problem with this?
now that Annabelle's caught up with the rest of us, we got 3.49, right? So if we have 3.49,
3.5.
the question is, what do we do with it? Okay? We cannot round down and we cannot round up. Okay? We cannot leave it at a half either.
That's what we did with the one.
All right, so this is 3.5. Have we written any formulas that were K1, CR1, O, 3.5 in the last few weeks? We're not starting today. Herman.
Like where it's like work to divide it equals 3.5 or something?
No, I want you to think math class. How do y'all get rid of a half in math class? You can't round. Multiply by the reciprocal. So what's the reciprocal of a half? 2/1 or 2. So we're going to multiply by 2. Okay. I realize math for some of y'all is not your strong suit, but okay, go back. Okay, we're not talking pre-cal here. We're not talking math 3. We're just talking some plain old math, middle school level. Okay. This is 3.5. Okay? 3.5. We need to get rid of the half. So we need to multiply by something that'll get rid of the half. So what's the opposite or the reciprocal or the inverse of a half? 2/1, or it's just a 2. Okay? So to get rid of a half, which is what this is, we multiply by a 2, and the half will go away. Okay?
Why didn't we do that for 1 then?
For what?
For the one that we had to round for one, it was like 1.22.
Yeah, but that was 1.00 something. That's the same as 1. That was like when we got 1.999 last week. 1.99 is the same as 2. Okay? But 1.5 or 2.5 or 3.5 is not the same as a whole number. That's in the middle. Okay? So,
It has to be in the middle for you to do.
yes. Now, to answer Nikaya's question here, some of you are going to get confused by this. If you get 1.97, what's 1.97 the same as? 2. But if you get 1.76, is 1.76 the same as 2? No, you have an error. Okay? It needs to be very close to the whole number. Okay? If you get something that's 4.9 or 5, that's a half. Nadia. Shh. Now, if you get something that's like 3.33, what's that? That's a what in math class? That's a third. What would you multiply a third by? 3. Okay? They should turn out to be fractions that you've seen before. Okay? I'll even be so bold as to tell you that I will only give you a whole number or a half. You're in a first-year class. I'm not going to try to trip you up. If this was an AP class, I would give you a 0.25, which is a what? A fourth. I would give you a third. I might even give you something that would be a 2/3. I'm not going to. You're in a first-year class. You will get a whole number or you will get a half. So if you get some weird number that's not a whole number or a half, you should know what? You did something wrong. Okay?
So
what's the answer after we multiply this?
K2,
K2, CR2, O7 is our answer.
The whole equation.
We just like in algebra class. Can you only multiply one number? No. You got to do it to both sides. You can't just do it to one. So if I multiply oxygen by 2, I got to multiply potassium and chromium by 2. Got to do it to everything. All right, so let's try a different one. We haven't done one that's in grams. And this one has a little bit of a twist to it. Not much.
Oh my God.
Not much.
That's too much.
But people like Annabelle will flip out if I don't talk about it.
Oh.
And then swear I never taught it.
What?
It's probably in the wrong spot.
It's still an empirical formula question.
No, like in the wrong spot.
You didn't put it with empirical formulas?
Nope. No, I just found a blank spot.
Okay, genius. I told you this was Friday, empirical
I know,
formulas.
but I thought that was.
Okay.
Okay.
Are we just doing this question thing the whole time?
No! We're going to learn a new topic after this one.
Practice besides empirical formulas.
I said empirical molecular formulas, then practice. So, when you finish writing this, I want you to tell me what's different about it.
I don't know what it was.
It doesn't give you something for.
Phosphorus. It's in grams. He said
It is
right.
phosphorus is the 10. Yeah. Then I don't know. It's already in one. Hey.
I know.
It is already in grams, that's one thing.
You have to find phosphorus.
I've had several people yell out that we have to find phosphorus, and that is correct.
Uh-oh.
I
I don't even know what this means. I'm confused.
Right.
Can I get the bill?
You have to use the percent thing that we.
Did you ever decide if you went to the thingy, did we get extra credit?
I have not decided. I'm still taking it under advisement.
Let's see how we do on the test tomorrow.
No. And then. Alright, she said to give us points. Miss Wall.
Nagging me will not help you.
Wait, who all was here? Was everybody? Oh, I'm trying to figure out.
Good looks?
I think I know her.
Nothing you guys did exactly that. When you did that.
So, the tin that was told. Yeah. So it's just, well,
Sorry.
okay, I thought I was just.
Oh.
All right, so have we got it written?
No. Oh, no. Annabelle, so what was up to leave?
Go.
Okay, so what do we need to do? We got to find the phosphorus. This tells you that it's the mass of the what?
The whole compound.
The whole compound. This is the mass of the what? So we don't have the mass of the what? So we need the mass of the phosphorus. Okay? So the 5.717 is grams of oxygen, and we need the grams of phosphorus. So we got to find it. What are we going to do? Exactly. That's all you have to do. All right, so 10.150 grams of the compound, which is, let me change that. That's phosphorus and oxygen. And we know 5.717 is grams of just oxygen. We're going to subtract, and we'll be left with phosphorus. So somebody do that and tell me what it is. 4.433.
Yes.
And that'll be grams of phosphorus. All right, so if I put this here, and I draw two charts, can y'all find the empirical formula?
Well, but it's already in grams.
It's already in grams, so you're ready to find what? Moles.
Oh, yeah.
So y'all are in grams. Find moles.
Wait a second. Are those meant to be double deckers or just
She
two
probably
seconds?
just-
Just making sure.
Oh,
I thought it was like that.
oh,
Wait.
I was scared.
So wait, you always put the information that they give you in the top left?
Yeah.
Okay. Because I have that confused.
Yeah.
The other group is affected.
What's wrong?
She said she might have to change the schedule.
Yeah, but she
Because
has
it's taking longer than expected.
Yeah, I would think wait a little bit. I would think we'd at least need some of them to come back.
Yeah, none of them are happy.
Why did it take us so long? It was.
Appreciate
I
it.
knew it.
Yeah.
It's so new. It took me like 30 minutes. Oh, they've been gone for 40 minutes. Okay, Ceci.
We don't need you to tell us how long they went for you.
It took me 55 minutes. When they have 8:30, I've done it 9:15. How much is that?
So, final verdict, we're waiting.
45 minutes, it'll be 45 minutes.
She's either a really slow reader, or she stalled, so she didn't have to go back to first.
I text my mom to see their answers on their stuff, because I didn't know.
Okay. So do we send the people at 10:50, or do we let them stay here a little longer? Well, okay, we're debating, because we still have 4 of them who haven't come back yet.
They in there working. I
Yeah.
just walked past the media center.
So we're voting for they wait until we see some bodies return.
That's probably it.
Okay. Thank you, man.
I'm trying to get to you Saturday.
It's
I
okay.
wanted to make sure.
Okay.
Thank you.
You're welcome.
All right.
All right, find me some moles, and divide, and give me an answer.
Oh, it's weird.
Oh, there's one body. We're debating whether the 10:50 people should go or wait.
There's
So
so
many people left.
There's what?
There's so many people signing up.
Okay.
They're not finished.
They're not finished yet? Okay.
This is not.
Yeah, they'll make it enough.
Okay, question, where do I get the grams?
Where we always get grams from on the test. There you go.
What else?
What elements do you have?
Oxygen and phosphorus?
So that's what you're looking up.
Right.
I know
Right.
it's-
And the oxidation numbers.
That's it. Yeah.
Because
You will.
We're gonna have to do the reciprocal thingy.
The what?
The reciprocal thingy.
Yes.
Oh.
Yes,
Doesn't matter which order they go in.
typically, they're in the order they appear in the question. So since phosphorus is first in the question, the elements are usually in the order they appear in the question. So phosphorus and then oxygen.
Okay,
So like 3, 5, 7. We just put 3.56.
You can. I usually take about 3 decimal places when you write down the
Or like 0.35, yeah, 3.2, like 3 times.
It doesn't matter if you round it up.
3, 5, 7.
Don't make any difference.
So you divide by the smallest number. Do I need a smallest? I'm not very confused. Do I need a smallest?
Yep, oxidation number.
Oh, 0.143.
You got 1.5. That's 1, that's 2.5. That's 1.
Oh,
Yes.
it's 1, now 1 divided by that.
Yeah.
Yes.
You can get the table divided by the smallest number. Usually it
So you have to get plus.
You just have to make it. She said.
Yeah. I know. Yeah, never mind.
What is that? It's really not, it's just like, you guys are
It introduced to like 7. Okay.
All right, did everybody get those numbers of moles?
Yes.
All right, so from that point, which number of moles is smaller? So divide by 0.1434 and you get a 1, by 0.1434 and you get 2.5. So when you write your formula, you have P1, O, 2.5. Now, just like we just talked about, if you get a half, you have to multiply your formula by what? 2. So you get P2, O, 5. Questions?
That's a lot of work.
Y'all are really not going to like the empirical formula or the stoichiometry problems we do next. All right. Now let's talk molecular formulas. Now, we talked a little bit about this on Friday. Now, molecular formulas show the actual number of atoms. They may Yeah.
The time is now 10:56. The 11th graders taking the ACT last name Pacheco through Stiller should be in the media center at this point. 11th graders Pacheco through Stiller should be in the media center at this point. Teachers, please check your email if you have questions.
Okay. Now, molecular formulas show the actual number of atoms. All right. You may or may not be able to reduce these formulas. Okay. There's 4 of you who are going, so make sure the 4 of you who are reminded are there. So, when we did this on Friday, we talked about formulas such as C2O4. All right, C2O4 can be reduced into CO2. So CO2 was the empirical formula, which made C2O4 the molecular formula. But do all formulas actually reduce? No. So if you have a formula such as Na2SO4 that we talked about, which confuses some people because the S has a what on it? It has a 1. This one cannot be reduced, right? It's already in lowest terms. So this one is both the empirical and the molecular formula. Okay, that one cannot be reduced. So it's both the molecular and the empirical formula. It's already in lowest terms. Well, to just catch up, pick up as best you can.
She said it's my birthday.
Happy birthday, and just do the best you can.
Thank you. Are you excited to share on your birthday?
Yes, I was so happy.
She has the,
How are you doing today? Going to a game.
At least you don't have to take the ACT on your birthday. It could be worse.
You're right.
well, I have to learn somebody.
Oh.
All right, you caught up? Or I should ask if Annabelle caught up. Are we good?
She's not.
Who's not?
Give her a minute.
Okay.
Give her a minute.
Must be that road.
You shouldn't have moved 6-7. No.
Sometimes, sometimes not.
I like my spot. You should move. Believe me here.
All right.
Believe me.
So, how are we going to find a molecular formula?
Great question.
All right. First of all, we need 2 things.
A calculator?
Nope.
Periodic.
Nope. Those are all givens for me, people. You have to have the empirical formula, and you have to have the molar mass. Now,
The molar or the molecule?
you can say molecular formula mass, gram formula weight, doesn't matter which name you use.
The molar is the.
Moles.
Wait,
Can I get it out? Can I?
Remember when we said formula mass? And it had like 5 different names? That's just one of the names. You will find that I will change the name as we go through the semester, because if I call it formula mass every single time, and you see a different name on it on the exam, you won't know which one it is. So it's just another name for formula mass.
So we need to do
Molecular formulas.
So do
We're
we?
talking about a molecular formula. Yes, sir.
Or is that how that's supposed to be spelled?
Empirical.
Oops.
Did I spell it wrong?
I thought it was
I thought it was.
IRA. Oh,
EMPIR.
Oh, I
IRA?
IR.
The IRA? much was your cup?
All right, now, we're going to start easy because I'm going to give you the empirical formula in the first couple. Now, because we already know how to find the empirical formula, after we've done a couple where I give you the empirical formula, what am I going to take away? The empirical formula, and I'm going to give you the percents, and you're going to have to do this piece first, and then find the molecular formula. So it'll be a combined question. So on Wednesday's lab, you'll have to do both parts of the question. You'll have to do the empirical formula problem first, and then the molecular formula problem second. And then you have to write the names. All right, so what are you going to need to do to find the molecular formula? You're going to take the molar mass, which is given, and you're going to divide it by the empirical formula's mass, which you add up. Yes, the molar mass has to be given. You cannot work the question if it's not given. Say what? No, you cannot solve for that. It has to be given. The molar mass must be given. Now, when we divide these two masses, you will get a whole number. If you do not get a whole number at this point, you have an error. Okay? It is that simple.
So do we have to round?
Nope. You will get a whole number. It might be like 1.999, or it might be 2.0,
So we still
or it might
round the answer if it's not a whole number?
it will be very close to whole. It might be 3.97, but it will not. If you get like 1.76, you have a mistake. Okay? It will be very close to a whole number. Okay? You will not have to multiply by any reciprocals at this point. Now, you will take this whole number and you will multiply it by the empirical formula, and you will get the molecular formula. I know you do. Okay? You will take the whole number and multiply it by the empirical formula, and you will have the molecular formula.
Well, how does that give you the formula? Okay, I don't even understand how you.
If y'all will shush and write it down, I will show you how it works.
No, not how it works. I'm talking about why would you even
Oh, wait, question.
Yes, dear.
Okay, so how we multiply the 2 times the whole formula? That's pretty much what this is? Okay, gotcha.
Yes. Now, the concept behind this is that the formula has probably been reduced. And we're trying to figure out what number the formula has been reduced by. The most common number a formula has been reduced by is what? 2. So a lot of times we're going to get a 2. And so we'll take the 2 and we'll multiply it through the formula to get the molecular formula. Sometimes a formula may not have been reduced at all. So when we divide, what whole number will we get if it's not been reduced at all? A 1. And if we multiply by a 1, we get the same formula. We're trying to figure out what number the formula was reduced by. Yes, ma'am.
So do we know it's reduced if it doesn't if it looks like this one?
Well, we'll have numbers. We're going to have math numbers. So we won't have a formula at all to begin with. Okay? So we're trying to figure out mathematically what the formula was reduced by. Okay? Because we've already done it with the oxidation numbers that way. So now we're doing it with math. All right? So, yeah. I don't care.
You go back.
Sure. It's like having Annabelle there.
I've been waiting 6:40 and I couldn't wait any longer. This happens that way. Sorry.
Tell me when you have it, Noah. You got it? Got it. So here's a typical question.
Can we write that?
It's your choice. There's no, it's a sample.
So much writing.
This isn't much writing. Word problems get much longer as the year progresses.
It gets longer than this.
Yeah,
Why?
they just do.
I felt like
I'm just taking a picture.
I summarized already.
So what's the point of finding molecular formula?
We don't need it, but it's a skill that's required.
Is it just because chemistry is complicated? Is it just because chemistry is complicated?
All right, so what do we do? Do we have the two things we need? Yes. So this is the simple version. You have the empirical formula, you have the molecular formula. We have the, sorry, I said it backwards. We have the molar mass, we have the empirical formula. All right? If I flip ahead a couple steps, all right, this is the complex version. All right? See how you don't have the formula? You have to find the formula. This is why I said this is the simple version. You already have the what to start with. You already have the formula, okay? So this is the easy version. We have the empirical formula. We have the molar mass. So the steps are take the mass that's given and divide by the mass you add up. Well, the mass that's given is 283.889 divided by the mass you add up. What was the only thing I have to add up? P205. All right. This is a skill that's on the test tomorrow, by the way. How do we add up P205?
You break it apart and then you find the mass.
All right. So break it apart. How many P's are there? How many O's are there? Okay. I'm using whole numbers. 31, 16. That'll be 62. I think that's 80. Oops. That'll be 2. And that'll be what? 14? 142? All right, so 142 goes here. Now, when I divide, we have to get a what?
A whole number.
Somebody divide that, tell me what I get.
2.
1, 2.
Are y'all sure?
Yes.
Okay. Now, this means the formula was reduced by 2. That's what we just found. That was the reason we divided, to know what the formula was reduced by. Okay, that was the whole purpose for doing the division. Now, we're going to take that and we're going to find the original formula. So we're going to take the 2 and we're going to multiply it by the original.
When I get my grades back.
Apparently, I need to talk to Kevin about this because it's happening more and more. I was writing 2 times P205, by the way, if you want to finish what you had. Because it may not come back exactly the way I had it. So, what would you, where'd the tissues go? Are we out?
Right.
Is it in the trash?
No.
Who took the box? Oh, it is done? Okay, let me go get one of the boxes Herman brought us.
Used it all last week.
Yes, and I'll try that.
Instead of buying her boxes.
So the answer would be 4010.
Yes.
Thank you. Okay, that makes sense.
That'll be the first time.
So let's just shut off.
And so that's really,
It happened last week too.
I like
That's you're not a good friend.
I do.
I'm gonna have to start lying on my taxes. It was like extra tips. Sorry.
I knew that, but I didn't know.
45.
Same. When I get the answer, I know, but I just didn't know.
I just want to know my
I need to do that.
When did you have like, what did you do?
On the essay, I know I didn't use because I had exact tips.
Oh, that's
In the middle of the.
There you go.
I think I'm about to die.
You recommend
Woo!
Get my seat. Shut my side.
I see my total said $7,000 for the whole year. I was like, where is it? Because it's not in my bank account.
What?
The higher
I'm lost. Wow.
I
didn't even
Hello, Tom. He said, thank you. Or he says, have a nice day.
Every time.
He is 20 over. I didn't know he had the receipt. I see his name tag. I see it. Be serious.
Oh, yeah.
He said, thank you. And I just got up and left. I didn't say it back. And I was like, we didn't talk like it. I was like,
If you were so nervous,
I started like sweating.
it's
not that it's really.
Yeah, I
I will slow you down. It's so funny.
Yep. Figure when you come back. All right. So we had 283.889 divided by 142 was 2, and we had 2 times P205, right?
Right.
Now, when you do that, you get P4010. Okay, you with me?
That's what we're gonna do.
All right, can you do that one?
Wait, come back.
Oh.
That's the molecular formula. I know it's not that bad. They're just whiny.
Give me a minute. First of all, I was like,
we need extra attention. No, first of all, we're not whining, we just need extra attention.
we need extra.
You don't need a lot of it.
We're like
a needy.
We're just a girls that have a boyfriend that only plays for.
All right, do this.
We need more attention.
For next year.
60-year-old girl.
All right, find me an answer. Find me the molecular formula.
Hey,
Okay.
Annabelle, find me the answer.
I think I'm just gonna do it. Because it's not a homework grade. It's like, isn't it usually it's a three?
Alondra, find me an answer. Don't encourage Annabelle, find me an answer.
Okay.
She doesn't need anyone to distract her.
The simplest mean empirical.
Yes, it does.
You know.
Just let it be quiet.
Could we ask you, is there
Simplest is another way to say empirical, because remember, empirical was in lowest terms. It was, so it's just another way to say the same thing.
So this one we have to find the empirical.
Yeah.
So this one we have to find it.
Yes, simplest and empirical mean the same thing. Only I think simplest is spelled wrong. I don't think that other
Yeah, that's
I.
definitely not how you spell it, but it's good.
I tried.
Yeah, that other I doesn't belong there.
Shut up.
Thank you.
Hey, Melissa, which game you going to? You're like,
What game?
What game are you going to tonight?
are you going to East or here?
Are you gonna come to the game home or away?
I mean, I know we, but girls are.
Girls play at East, boys play at home, versus Central. This to me.
Whatever.
Didn't we lose against them? Right, they come in tonight, they said, oh yeah,
Go back.
they said, oh, we're going to.
It's my whole team.
What's at East?
It's my whole
Like,
team.
I play at East, boys play at home.
Wait, Central band?
Those start at Central.
When did you start?
They could beat us one time.
Alright, do we have the answer?
No.
Well, why are we having a basketball discussion if we don't have the answer?
I'm not.
I have the answer now.
Annabelle, what's the answer?
Like, I honestly,
I know the girls want.
should I have gone to the bathroom without you do that?
Can I run the ball?
Anybody?
Sure.
Nice chance. Was a good chance.
Caleb, you got the answer?
So C
And why are you talking about basketball?
So CH. H would have one, so we just divide one by their salary math.
You gotta find the math.
Yeah.
That's the math of CH.
I know it's on like the sheet thingy, but like, so we do this thing where we like times it by the subscript and then add it together.
Guys, find the mass of CH. Okay. So what do you do with that 13?
Round.
Right. Where did the 13 come from?
Right. Goes on the bottom. I found it.
For those of you who are yelling, I don't know how to do it. That's why we take notes. Find the molar mass. What mass did they give you in the question?
I thought they already gave us the molar mass.
That's right. So you write 78 on top,
Right, that's what I did.
divided by the mass you add up. What do you have to add up? C and H. All right. So that's on the test tomorrow, being able to add up C and H. How many C's are there? How many H's are there? Where do you find the mass at? So what's the mass of carbon?
12.
And several people said, can I use whole numbers? And I said what? Yes. 12 and 1. So 12, 1, what do you get?
13.
That goes on the bottom.
Too much.
So 78 divided by 13 is what? 78 divided by 13 was a 6. What does that 6 mean? It was reduced by 6. So now, if the formula was reduced by 6, what do we do with the 6? You multiply it by 6. 6 times CH. So you get what?
C6H6.
But I thought we were finding empirical.
The empirical was given. This is the empirical formula.
Look at the molecular.
You're finding the molecular formula.
I asked you earlier, if that was the molar mass, you were like, yeah.
That is the molar mass. This right here is the molar mass.
But why are we multiplying?
Because you got to find out what the original formula was. This is the reduced formula. You're going back to what it was before it was reduced. Shh. Those of you who are talking, stop. While Linda asks a question, the rest of you should be quiet. Whether you're interested in the question or not, it's rude.
I thought we were looking for it.
No, you have the empirical formula. That's given in the question. The empirical formula is found by doing the charts and taking the grams and changing them to moles and dividing by the smallest number. That's empirical formula.
So that number is just the molecular mass, but we were finding the molecular formula?
Yes. You can call that number the molecular mass or the molar mass. Those are two different names, mean the exact same thing. Nikaya. Okay? Are you with me?
Yeah.
Now we have to combine the two processes. On your lab Wednesday, and they're being graded for right and wrong answers. All right? You have to take both processes. You have to write it down. You have to be able to take the percents. Yes, it's a new question. And take the percents, find the empirical formula, then do the molecular formula, and then you're going to have to name the compounds. This is not one you'll have to name. It's not hard.
Okay, so it's not.
And you only get 45 minutes to do 5 questions, and there's a bonus if you want to try the bonus.
Wait, well, if we get the bonus wrong, that kind of gets us.
If it's a bonus, would I ever count a bonus against you? No.
We're attempting it if we get it right.
Yes.
This is really time consuming. Well, it's not hard, it's just you know, you just have to think, and it's a Monday. Oh, Jesus Christ.
He's here for some of you and not others.
Who is? Jesus Christ. What does it mean by mass? I mean, she wouldn't be wrong. Hold on. What's that mean? No. Is that division? Anybody have 30 cents?
Now, so when you look at this, did the formula get provided for you this time?
No.
No.
Backwards.
So you have to find the formula. So you're starting with empirical formula, okay, which is not provided. So what did we start with at the beginning of class?
We changed from percent grams.
All right. So you're going to start, all right, by finding the empirical formula first. Okay? So what you have to do first, it's not given. So what do we do with the percents? Change it to grams. So 85.64 grams of carbon and 14.36 grams of hydrogen. So we've changed them to grams, and I went ahead and drew the mole charts. So what has to go on the bottom? Grams goes on the bottom. Okay. And Asia said 1 mole on the top, and I'm just going to again use whole numbers. 12 and 1. Mm-hmm. All right. So once we have our moles, what did we do after the moles? Divide everything by the smalls. which is 7. Good. So it's going to be 1 and 2. Okay. So that's C1H2 is the empirical formula. Now, is that what they asked me for in the question?
No, that's for the.
So essentially, we've done half the problem.
Okay.
That's only half the
But this
question.
is on test marks. I'm not a pro at it.
So you're happy. So 1.542.08 divided by.
Yes. Wait, what?
Okay. So now we need to do the second half of what we've learned. So we need to take.
Go to starting page.
I can. All right. All right, so what number do I need to take out of this problem? I need this number right here. Okay, so I'm going to take the 42.08 and I have to divide it by what? What do I need to put on the bottom? I need to put the mass of my CH2. So I need to take this and I need to find its mass. So I'm going to take, how many C's do I have? How many H's do I have? What's the mass of carbon? I'm going to just round to a whole number just for today. Hydrogen has a 1 for a mass. So I get 12, I get 2 for a total of what? 14. Is everybody okay with how people who yelled 14 got 14?
Yep.
Okay, so where do I put that?
Under 42.
Under 42. So what do I get when I say 42 divide 14? 3. Okay, so again, that tells us the formula was reduced. Whoops, got a little bit carried away there.
All right.
All right, the formula was reduced by 3. That's what that 3 tells us. So you need the original formula. So what do you do with that 3? So 3 times CH2 is what formula? Are you with me?
Yes.
Okay. Now, for our practice, I need you to find, remember that worksheet I told you all not to misplace the other day that looked like that photocopied textbook stuff?
It's like, yeah, multiple stuff you said don't go.
Yes.
What's the name of it? Oh, I wasn't here for that, and I got a 0 in the group of right now. It says follow-ups and application. Because you said that you weren't going to make me do that at home.
I did not say that.
Yes, you did.
No, I didn't.
Because you were like, we'll just wait till tomorrow.
You're even making up genius.
I left mine at home.
Here.
Is it this one?
Yep.
Okay.
You left it at home.
It's
Because I didn't think I did.
What, you don't have one either?
Where we did.
Yeah.
That's why I'm going to need one. You don't have one either?
So are we ever gonna switch seats?
I don't know.
I mean, I don't want to like that.
I like my
What's it?
Do you like it or do you hate it?
I like my I hate it.
Right?
You say you'll fly in front. So I'm ready to leave this class. After this class, I'm ready to go for the day. I love the title. I have Jess though. I have your book, the Ninja Ship.
And was it down?
Annabelle, you ever get back up? Annabelle. You look like her.
Anybody else not able to find it? All right. Annabelle, sit down. All right. We're going to do question number, nope, 10B. Yeah. We're going to do 14, 15, under the problem side.
So we're doing the whole 14 and 15?
There's only one question.
Or application problems.
16, 18, B and C, and 19.
This is for homework, right?
This is for the remainder of class and homework.
Yeah, which side?
It's on the problem side. Some of us are struggling as it is. I don't really think we need the application problems currently.
Right.
Because it is there. I don't alter the worksheet based on what I might want that particular moment in time.
I really don't think it's all like so.
So, now, for homework tonight, what should you be doing? Studying for the test. Now, when is it that we will go over this?
After the Wednesday.
We will go over this Wednesday. Annabelle, from now until 11:40, you need to be doing this.
So they go, this is due Wednesday.
This is due Wednesday if I check homework. Okay?
You should.
The lab on this stuff is Wednesday. If we finish the test early tomorrow, we will not be doing this after the test. We will move on to chemical reactions.
I have 2 tests tomorrow. I'll do that today.
Okay.
I have to be ready.
Now, if we're going to talk now and not work, then we'll move on to chemical reactions now. Then work on the assignment.
So, for 10, it's basically like
It says percent composition, just like the other. Number 10 is like the opening.
So like that. How many, like, yeah, and then you multiply by the atomic mass, and then you add them all up, and then you divide
What?
by each of the determinants.
No,
And
you
then
have to break
divide
the parts up. No, you break it apart. So you distribute and have N and O separate.
There's no parentheses.
Oh, I'm thinking about the next one. I'm thinking about C. Excuse me, I was thinking about C. No, you would not have parentheses on B. I was on C.
Because there's no parentheses, so you don't have to distribute. So it is just one. I don't know what 107.8 or something. Because you don't have to distribute.
Yeah. What?
I'm gonna cry.
When I do answer keys, most of the time I do not round. I usually only round when I'm doing work on the board. Like tomorrow on the test,
Okay,
when I'm doing
felt
answer keys,
that.
I'm not.
I don't even know what you said.
But typically I don't, but it's fine if you have, or you do. Yes, we're working on our homework.
Tomorrow, all we're doing is discuss.
If we finish early, which honestly you should finish early, we'll work on chemical reactions. It's only 45 questions.
Even if I try to
With
take
a lot of
math.
We have Annabelle in our class.
It's not the only one that's gonna take forever.
No, well,
Basically.
from today's questions, I can,
She finished first on the last test we took.
Yeah. I pass.
I just don't, when I'm testing, like, I don't go back, I don't